Let us consider a function f from a to b and another function g from b to c. There is a connection now. Set B, codomain of f, is now becomes the domain of g. Then we define the two following compositions. One composition is GOF, the second composition is FOG, read as this O, or F composition G or G composition F. This means G composition of f of x will be the functional value of f of x is put in g of x, and that is the final result. This implies f of g of x. The functional value of g of x is put in f of x, therefore that becomes a new function. These two composition functions may be equal or may not be equal. For example, let's take f of x is equal to 2x and g of x is equal to x plus 1. I would like to find out GOF of x. It is g of f of x, that is g of, in the place of x belonging to g of x, you replace g of 2x, that is equal to 2x plus 1. That is GOF of x. Let's consider FOG of x. It is f of g of x, which is function value of g of x. G of x is now x plus 1. Replace the x belonging to f of x by x plus 1. It becomes 2 of x plus 1, which is 2x plus 2. These two are not equal. Therefore, GOF in general need not be equal to FOG of x. Among the composition functions, we try to compose or composition of the function with its inverse. To understand the inverse part, I need the definition of identity function f of x is equal to x. So f composition f inverse of x is identity function of the domain of f, or f inverse composition f of x is identity function of the domain of f inverse. For example, let's take y is equal to 2x plus 7. In the previous example we saw it. Therefore, this implies our f inverse, this was f of x as 2x plus 1. This implied f inverse of x is x minus 7 by 2. Let's compose f composition of f inverse of x. That is f of f inverse of x. That is f of x is 2x plus 7. F inverse of x is x minus 7 by 2. So replace x by x minus 7 by 2. So 2 into x minus 7 by 2 plus 7. We cancel 2, we get x minus 7 plus 7, which gives you x, which is the identity function in A. Thus, it is proved that composition of function and its inverse is always an identity function.